So, just a little bit of background before we get going. Like I said, my name is Trev Harmon. I work for Adaptive Computing, and we are the ones, if you don't know, who make the Moab scheduler. We're also the corporate sponsors for the open source projects Torque and Maui. And so, we come to the show partially, well, obviously to come and sell our product, but also be able to spend some time with the community and see what everyone is doing with our products and what everyone else is doing here. Because you know what? As the last presenter in the session said, the community here is doing some amazing, crazy things. And what I'd like to do today is spend a little bit of time talking about what we see coming up in the future. And I also want to spend a little bit of time looking back in the past to kind of give us some context in really where we've come from. So, with that, starting in tools. From the very, very beginning, mankind likes to build tools. We like to make things to make our lives better, to make our lives easier. And we start with some really simple ones like this, some that now today, we don't really use very much anymore, and then have slowly, over many, many years, gotten to this point, right? So we have these great big supercomputers, and they've been evolving. So stuff that was this size 50 years ago now fits on, my phone. And it's just really amazing to think about where we are going to be going. We spend a lot of time as an industry and as a community looking off into the future, trying to figure out what it is that's going to be coming, what's going to be happening next. And one of my favorite bands, which kind of dates me a little bit, is Counting Crows. Absolutely love them, they're great. And they have a song, Mrs. Potter's Lullaby. And in there's a line that says, if you've never looked off into the distance, then your life is a shame. And you know what? That's true. Also, I don't think we have that much of a problem here as our industry doing that because we're always looking off into the future and the very next thing. I remember back when, we finally got the petascale, we got it in, and I was reading through one of the industry rags and found this article that basically said, if we were to go and build, the exascale using the stuff that we have now, it would take the power of a small city to run. Well, it didn't say small city, it said small medium city, and I think they probably meant medium city. Went down through all of these different things, and I think the one that really stuck with me the most is they said it would take so much hardware that the mean time between failure on the machine would be 18 seconds. So you boot up the machine, say run limpak, which is probably going to take 2 days, and 18 seconds and it fails. Okay, so we've been spending all that time since then trying to figure out, okay, how are we going to deal with all of these issues? So let's take a minute here. So here we are today, Denver, Colorado, 2013. And I want to go back, and not just a little bit. So not back to the 2000s, not back to the 1990s. I want to really, really rewind us back to 1966. Okay? Some of us in this room were alive in 1966. A number of us in this room were not alive in 1966. Me, for example, not alive in 1966. Has anyone ever seen this picture, this book that I have up here, this piece of old technology, this tool? Anyone ever? No one's ever seen it? I have a copy of it right here. Now, in presentations, I always say reading off your slides is a really, really bad thing to do, and I completely agree with that. Me standing up here and reading off the slide is bad. So I'm not going to do that. Instead, I'm going to read out of the book, which is probably just as bad. But my only choice was I either read out of the book or I put it up on the slides and read off the slides, at which point I'm breaking the rule, right? But I want to do this to get just a little bit of context in and us to think about where we are and where we've come to. So, going into this book is written by a Mr. Douglas Parkhill. Now, this picture is the only picture I could find of him on the internet. It's from a newspaper in Canada. He's a Canadian. He's a professor. And he said, back in 1966, as generally envisaged, a computing public utility would be a general-purpose public system simultaneously making available to a multitude of diverse geographically distributed users a wide range of different information processing services and capabilities of an online service. Yes, in one sense, he is definitely a university professor, and I can say that because I was one. As in any utility, the overhead would be shared among all users, with each user's charges varying with the actual time and facilities used in solution of his problems. Ideally, such a utility would provide each user, whenever he needed it, with a private computer capability as powerful as the current technology permitted, but at a small fraction of the cost of an individually owned system. Furthermore, since the user pays only for the service that he actually uses, a man-machine interactive operating mode becomes economically feasible. In such a mode, the human sits at the console and works directly with the computer so that the machine becomes a sort of intellectual partner, responding immediately to the queries of the man, questioning his errors and amplifying a millionfold his effective mental powers. 1966. It's talking about the idea of having computers as a utility, just like we take the lights in here for granted, right? We come in, we flip the light switch, the light goes on, and he says, that's what computers are going to be. That's what we're going to be able to do with them. Now, there's kind of a question here. So is what he's talking about, is this cloud? Okay, I have a friend over in IBM, very, very high up in the engineering department, actually in the whole organization, read that, or gave him that section to read. Took a look at it, he said, that is cloud. That's the definition of cloud. And I agree with him, it is. But I also want to say it's even beyond that. It's not just about cloud. It's going to be about what we are doing as a community. And so what I want to spend some time today talking with you about is how we as a community are going to be going and fulfilling this vision that was put out in 1966. I mean, if you think about that, that's nearly a half a century ago, where he said, this is what we're going to be able to do. And I think we've fulfilled a lot of it, and I think we're right on the cusp of bringing all of it to really be really be out there, to really be fulfilled. When I was taking a look at this, thinking about it, what am I going to say, how am I going to talk about it, I got this little thing kind of coming in the back of my mind saying, you're oversimplifying, you're oversimplifying. Okay, and so I'm going to admit right now, this slide is going to be very much an oversimplification. But I think it makes an important point. So right now, we go out and we look at the industry here, and we have HPC, and we have big data, and we have visualization, and we have scientific computing and technical computing, and on and on and on and on and on. And it's great fun trying to explain to my marketing department, here's how all of them fit together, and all these little nice, neat Venn diagrams. Okay. Here is the point that I'm now going to completely oversimplify, which is I'm going to say, for just a moment, we're going to suspend belief, and we're going to say we're going to take all those and make them just computing. We're going to be providing computing out to the industry. And it's really interesting, as I go and I talk to different verticals and talk to different people, there are many places out there that are basically, for all intents and purposes, doing HPC work. Okay, their workload looks just like HPC workload, except they all have completely different names, completely different nomenclature, and if you were to mention to them, you're doing HPC, they're like, no, 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 this is not HPC. Well, yes, it is. No. And I think that's also one of the reasons why we're seeing more and more industries that are coming and looking at what the HPC community has been doing for many years, and starting to see that they're trying to solve problems that we have already solved. And I think there are a lot of those. So let's kind of talk through some of the things that we have happening. So yes, here's our big center, right? And we have all these different areas that we're doing stuff in. We're doing stuff in energy, we're doing it in manufacturing, we're doing stuff in energy, so on and so forth. Lots of different people, lots of different users, different needs. Okay? So we have our core of HPC, which is the really high performance, high-end supercomputers. You know, the great big ones that all of us, would love to be working on. Between you and me, I actually have kind of secret fantasy of getting on like one of the top 10 and just submitting one job that uses up the whole thing just to play a great big game of Pong. Just 'cause. So we have all these different industries, different things people are trying to do, and we're now starting to see, in my opinion, workflows that are happening. One of the very first workflow that I think we've seen on the HPC side is this one right here. So not just stringing our batch jobs together, but saying, okay, we're going to take our HPC jobs, we're going to run them. Once they've run, now we're going to hand them off to the next stage, which is virtualization. Okay, so we can, or not virtualization, visualization. So we can come in and actually manipulate and see what that's doing. And that's using potentially completely different parts of our data center, completely different parts of our HPC cluster to do that. It's a workflow. And what we're seeing from our side as we're looking in from adaptive computing, this whole idea of workflow is going to continue to grow and get bigger and bigger. I'm going to give some examples of this. So let's just imagine here for a minute. Okay, I'm going to say the word cloud. 2 years ago, here at this conference, I think if I'd mentioned cloud and HPC together in the same sentence, we would have had a little bit of an issue. Kind of like 3 years ago, had I mentioned virtualization and cloud together, or virtualization and HPC together in the same sense. We weren't really quite sure. Now, we have seen and we know that there are places, there are times, there are workloads that those match up with. So let's just envision this. We have our scientists. The scientist comes in and they say, okay, I need to do this problem. First thing I'm going to do is I'm going to bring up an environment, a cloud environment, so I can sit there, I can work and get my model ready. Once I have that model ready, I may run it through some scientific computing applications that cloud is providing to me to, again, get my data set where it needs to go. Next, maybe I'm going to drop it into some type of a big data application so I can get the data reduced down to what I really want to do for my parameter sweeps, which are now going to be done by HPC. And then after that, just like before, we're now going to have our visualization where I'm going to be able to go in and actually see what those results are. I think we're really getting to that. Earlier this week, we announced along with Intel that the Moab scheduler is going to be working with their Hadoop on HPC system. Basically saying you can run Hadoop on an HPC system without having to make any major changes to that architecture. Okay, again, another one of those things where we're seeing these types of different areas that used to be these silos come together to really do what we want here, which is we have our jobs, we have our workload, we have our problems, what we're trying to solve. What we need to do is take those and match those up with the resources that are best able to do that. That's the exact same thing that we've been doing, from the scheduler side, since the beginning. How do we get the best use out of our resources? Now, as we're going forward, we're going to, I think, see some changes, not necessarily at the great big, at the high end of the top 500, but in centers that are trying to solve a multitude of different cases or trying to serve many different organizational needs. So let's look at a couple of these. So for example, topology awareness, okay? This is a big one for us right now, which is how do we make sure that the jobs are being run in such a way that they're placed appropriately so we have the least amount of network interference that happens, that we have the best throughput that we possibly can have, okay? Clearly, an HPC problem that we as an industry are trying to solve. We have a demo in our booth, but our booth at this moment is currently being torn down up on the show floor. This is dealing directly with this. The same thing applies to any other computing problem where we have parallelized code that needs to be talking to each other. So whether or not it's an HPC problem or a big data problem or scientific computing problem or technical computing problem, if there needs to be this communication, topology awareness, an HPC problem, is going to be solving those needs as well. Another one that we see all over the place, I think, is this idea of data locality. Whether it's an HPC problem or a big data problem, where our data sets are and where the data goes after we finish is a problem that has to be solved by all of us as we set up our centers, right? So we come in and have to figure out how are we going to deal with this particular issue in our particular area. Again, another HPC problem, what we consider to be kind of our own problem, that has application all the way across all of these other types of computing, and will definitely become an issue with these workflows. Also as well, this idea of hardware preferences. Now, one of the things I've heard is, I've talked with other people about this idea, is they say, well, you can't build a data center, and wire the whole thing up with InfiniBand and everything else and then use it for these problems that don't really require it. I don't see how that's any different than some of these other issues that we've already faced in the past, right? I mean, many of us, as we build our clusters, we put our first set of machines in there. A couple years later, we get some more funding, or the next year we get some more funding. We don't buy the old stuff, we buy new stuff. Next time, we buy the newer stuff. So after a while, our cluster that started off all nice and neat and the same, homogeneous, has now turned into this heterogeneous cluster with different types of hardware, okay? From adaptive computing's point of view with the Moab scheduler, one of the big things we work with people on is making sure you get the right jobs on the right type of hardware in the right order, because you have some jobs it's okay to run on the slow machines. Some jobs have to run on the fast machines, some don't care. Some have specific requirements. Some machines, I think, in our systems for quite a while are still, we may have some that have GPUs on them, some that have mics as we bring those in. So again, this hardware preference problem is currently an HPC problem, but again, as we have these ideas of workflows, as we have big data, as we have other types of cloud infrastructure seeping into our systems, where you place those is going to matter. One other little merger here that we're seeing. So here's our workflow again. If we just take out two of these, we have our cloud and HPC, which gives us HPC Cloud. And this is one that this year at the conference, I've been really, really surprised by the sheer amount of different sessions, talks, booth presentations that have been dealing with this specifically. Because it's one of those things that, again, I think there's been a shift in some of our ideas about how computing should work, especially high-performance computing. Again, last year, the year before, you say HPC Cloud, you get the response of, it's not high performance because it's not high performance, it's in the cloud, right? No high-speed interconnect, so on and so forth. So now this year we're saying there are certain problems, there are certain sets of things that it does make sense to run out in the cloud. Certainly, there are some things that will never make sense, in my opinion, to run out in the cloud. There's nothing, it's like getting custom-made clothing. There's nothing like putting on a piece of custom-made clothing that's fit exactly to you. It just goes on, there's no stretching, pulling anywhere. It feels great. That's what we do with our really high-end, high-performance computers. We tune those to the very, very, upteenth level to make them absolutely perfect for what we're doing. And there's always going to be a need for those. Then, again, as we have all these other people coming into our community, they have different types of problems that, okay, yeah, maybe they don't technically qualify as high-performance computing from our traditional definition. They still have the same types of needs, the same types of hardware requirements, and the same type of SLAs that the HPC community has figured out how to be providing for many years. So, I think one of the biggest problems we have with HPC Cloud, and I'm going to admit this is very, very silly and chintzy, but I just had to put it in. This is my HPC Cloud, see? HPC in the cloud, right? One of our biggest problems is how do we define it? When we say HPC Cloud, do we mean, running an HPC cluster entirely out in the cloud? Do we mean that we're going to cloud burst when we have excess capacity? Or excess demand our capacity doesn't meet? Does it mean that we're going to VM encapsulate all of our jobs so that you now magically have checkpoint capabilities that you've never had before, but you're taking an overhead hit for it? I don't know. What exactly is HPC Cloud? I've talked with people that have given each one of these things as their definition. And I think that's also one of the things that we're struggling with still just a little bit. And that's also why, at the very beginning of this talk, I said I was going to very much oversimplify, which is just say we're going to call it computing. We're going to just say we have these computer problems, and these computer problems have resources that they need, and they're specialized resources that they need, and we're going to figure out how to match those up. We're going to have our scheduler be smart enough to be able to say, okay, for this particular type of job, I run it here in my HPC enabled area of the cluster. This other one, we're going to build a VM because that's what the user needs. Here, we're going to be setting up a little Hadoop cluster encapsulated to run the map and reduce. Okay, when that's done, we're going to take that out and put something else in. Okay, because I think as we go forward, other than certain, certain systems that have very specific requirements, very specific directives of what they're for, we're going to have more and more users who are coming to us as administrators saying, I need this, I want this. How can you help me accomplish this? Because really, what we're all here for, whether we're hardware vendors, software vendors, admins, what we're all really here for is to help our users, right? We're all here to help them accomplish what they're trying to do because they're trying to solve the problems in this world that really need to be solved. So with this HPC Cloud, I'm going to say, look, it depends. Your definition should be able to be whatever it needs to be for your particular users, and your software should be able to support that and help you be able to do that, because really it's all of these different definitions of workload that I think we're going to be needing to address as we go forward. So here we are again. We have all the different industries. We have everyone coming in. We have the need to be able to support these different things. The idea of workflow, tying together different types of computing to make that work is really what we need to do. And I think this last point here is one of the most important. The HPC community has solved, or is in the process of solving, many of the problems that the rest of the world that's now coming into large-scale computing is now having to face. And we have this great opportunity as a community to go out and to help these other industries leapfrog what's taken us the last 10, 15, 20 years to learn. Which then takes us back to Douglas Parker. So I'm going to read one final section out of this book. This is in the conclusion. Now this is after he's gone through, he's described the system, what it should be, all the economic, governmental, legal, social impacts that this is going to have. And this is how he starts to wrap up his conclusion. He says, "It is the writer's hope that out of the discussions in this book, a clear picture of the computer utility will appear. In this picture, the computer utility constitutes neither an ostentatious term for a superior sort of service bureau, nor yet a fanciful excursion into the realm of science fiction. Instead, it represents a natural extension of familiar technology in such a way as to create a revolution in the distribution and utilization of computer power, a revolution that promises ultimately to make that power as freely available as the telephone service of today. Out of this availability will flow social changes and opportunities for human development that promise to make the last decades of the 20th century among the most critical that the human species has had to face during its million-odd years of existence. The present state of the computer art is advanced enough to permit the immediate construction of many useful types of computer utility, but the full exploitation of the concept will obviously require major advances in the entire field of computer technology." Again, nearly 50 years ago. And what I would say with this is, I think we're just about there. I think we're at the point where we've finally got the computer technology that we need. We've figured out the storage issues. We've figured out many of the networking ones. I know we spend this whole week talking about all the problems that we have and that we're trying to solve and trying to figure out what to do. And everyone's bringing in different solutions and we have arguments over which one is best. But really, look at that, 50 years. I think we're just about there. And so yeah, this is my invitation. Come join us. Come join us on the rest of the journey, because we're just about to fulfill the vision from a half century ago. Thank you.